Hello, students. So we've got a little work with L'Hopital's rule here, and in another video, I will move on to the Maclaurin series problems. So right now we've got L'Hopital's rule, and the basic idea is that you try to evaluate the limit by substituting, and if you obtain an indeterminate form, which means either 0 over 0 or infinity over infinity, then you could take the derivative of the numerator and denominator and try to recompute the limit. We're not doing the quotient rule. We're not taking the derivative of the fraction. We're just taking the derivative of the numerator and the denominator as separate functions. So I'll just do a couple here. Problem one, when we substitute 0 in, sine of 0 is 0, and if you plug in 0 for x, you get 0. So that's an indeterminate form. So we can take the derivative of the numerator, which becomes cosine of x, and the derivative of the denominator becomes 1, and we can come back and attempt to substitute our limit again. So as x approaches 0, cosine of 0 is 1. There's nothing to plug into the bottom, so we get a value of 1. If you look at sine of x over x on a graph, you'll notice that it doesn't exist at x equals 0. There's a hole there. However, the graph from both sides is approaching a y value of 1. Let's try one that looks a little bit more interesting. How about part D here? Okay, so if we try substituting x approaches 3, if we try substituting 3, we get e to the 3 squared minus e to the 9. That's going to be 0. And 3 minus 3, that's going to be 0 as well. So what we do is take the derivative of the top. The derivative of the top is e to the x squared times 2x. E to the ninth is a constant, so I eliminate it. The derivative of the bottom is 1. I'm taking the limit as x approaches 3. Now it's just substituting. So I get e to the 3 squared times 2 times 3 divided by 1. In other words, 6e to the ninth. Let's do one last one here. Let's see, what's an interesting looking one? How about part H? That looks fun. Let's do part H. So here we go. Let's first plug in 0. On the bottom, or on the top, we have the sine of 0 squared, which is 0. On the bottom, we have the natural log of the cosine of 0. And if you think about cosine of 0 is 1, natural log of 1 is 0. So we have another 0 over 0 indeterminate form. Just keep in mind you may get some infinity over infinity indeterminate forms. Just haven't seen those in the examples yet. So let's take the derivative of the top. The derivative of the top is cosine of x squared times 2x. The derivative of the bottom is 1 over cosine x times negative sine x. And let's try here the limit as x approaches 0. Okay, this is a little bit interesting because if I try substituting 0, my numerator is going to be 0 because of the 2x, and my denominator is going to be 0 because of the negative sine x here. So looks like we're going to have to do a little bit of work. So let's take the derivative of the numerator and the denominator again. On the numerator, I'm going to use a product rule. So we're going to have negative sine x squared times 2x times 2x. That's like f prime g. And then plus cosine of x squared times 2 fg prime. And then on the bottom, I'm going to think of it as a quotient rule, negative sine of x over cosine x. So the derivative of negative sine is negative cosine x. That's f prime times g minus f times g prime, which is going to be another negative sine x. All of that is going to be divided by cosine of x squared. And at this point, we just hope and pray that when I plug in 0, it works out to a number, and then I don't have to do another derivative, because that's going to get just real nasty if I have to do it again. So Let's move my face out of the way. So if we plug in 0 to the top, then I'll use pink to cross stuff off. If we plug in 0 to the top, whenever we see an x term, come on, computer. I just want to switch colors. There we go. Whenever you see an x term, like right here, that's 0. So this whole piece is going to be 0. Whenever you see sine, that's also going to be 0. So this whole piece is 0. I don't even really need to worry about the positives and negatives. And whenever I see cosine, I'm going to get 1. So after ignoring the pink things, we can say we have 2 times 1 on the top. That comes from right here. And on the bottom, it looks like we have a negative 1 divided by 1. So I believe that comes out to be negative 2. There is a small chance that I messed up my positives and negatives on that. But the point of that last example is you may need to use L'Hopital's rule several times in order to actually obtain a numerical value for the limit. So the process is you try to substitute the original value into the original fraction. If it's an indeterminate form, you take the derivative of the numerator and denominator as separate functions using the chain rule or the product rule or the quotient rule, whatever you need to do. And then you try to resubstitute. If you need the L'Hopital's rule again, you can. So that's it. Please let me know if there's any other problems you'd like me to do in a video.